Jena informat sewa illi dis-sena id-dinja tax-xjenza skoprit dana ħanaqrata ġifieri dana il-particle sewa dana il-partiċella li sejħula Higgs boson.
Ekku.
Issa sa xi ġimagħtejlu kieku xatt qalli Higgs boson kon naħsbu jew xi plazziri jew
Jew xi tip ta' hiccup.
Imma illum ħaniskopru x'inhu dal-imbirek Higgs boson, però ħaniskopru b'mod naqra iktar għalissa ħanibdew b'nota ħelwa, jiġifieri ma nistgħux naqbdu ngħidulkom da x'inhu. Allura kien hawn xi ħadd iktar kreattiv minna, għalax ma nagħmlux żifna ħelwa għalissa u nħaltu naqra x-xjenza mal-arti.
Mela artiċi nħallu fil-żeffina. Ninaw magħna iż-żeffina ta' Science in the City.
Most scientists believe the universe began in a big bang about 14 billion years ago. A millionth of a second into the Big Bang, there was a lot of potential energy to be translated into particles and atoms. At this stage, we have a universe of many elementary particles that are the building blocks of matter. They collide with each other at a frantic rate, but they don't really bind. What you have is a dance of particles moving around at tremendous energies, colliding with each other and creating more particles and more energy. As the universe cools and expands, these particles stop colliding so strongly and energetically. They have more time to look at each other and perhaps bind and do something. So in 1 second into the Big Bang, the universe starts to make nuclei. Protons and neutrons start to bind. At about 300,000 years, the nuclei bind with electrons to form atoms. Matter comes into existence and starts to take up space in the universe. A majority of this is hydrogen. These hydrogen atoms with gravity begin to form clouds. These clouds condense and get denser and denser, hotter and hotter. These clouds form galaxies and stars, 99% of which is hydrogen burning. Eventually, these stars have solar systems and planets form around them. So, everything you see and feel in the universe is made up of atoms. When we look at all this stuff, we can break it down beyond atoms. There is a lot more going on. We enter the realm of quantum physics, where everything is not what it seems. A world where things can pop into existence seemingly out of nothing and disappear just as quickly. A world where you can be everywhere in the universe at the same time, but nobody can know precisely where you are. According to our best theory of nature, the standard model of particle physics, this is exactly how the world behaves. Because at its heart lies the strange theory of quantum physics. Let me introduce you to a few of these strange particles. The quarks. Up and down quark. A teeny little point inside the proton and neutron. They are friends forever. Charm quark. A charming second generation quark. Top quark. This heavyweight champion doesn't live long enough to make friends with anyone. Strange quark. What's so strange about this second generation quark? Bottom quark. This third generation quark is putting on the pounds. Now for the leptons. Electron neutrino. This minuscule bandit is so light it is practically massless. Muon neutrino. Like the other two neutrinos, he's got an identity crisis from oscillation. Tau neutrino. He's a tau now, but what type of neutrino will he be next? Electron. A familiar friend, this negatively charged busy little guy likes to bond. Muon is a heavy electron who lives fast and dies young. Tau is a heavy muon who could stand to lose a little weight. Here are the theoreticals. Dark matter, the mysterious missing mass, difficult to see because he's so dark. Graviton, still unobserved yet theoretically everywhere. He's got big legs for jumping brains. The force carriers. Photon, the massless wavicle we know and love. Gluon, the glue of strong nuclear force. Z and W boson. As the carrier particles of the weak nuclear force, they are downright obese. Nucleons. Proton, we would not be here without her positivity. Neutron, he insists on remaining neutral. And finally, the Higgs boson. He's the one everyone wants to meet, and now we have seen his signal from years of data. You'd be smiling too if everyone was looking to interview you.